When we think about our planet, we usually picture the world we live on, right? The land, the air. But what if I told you that's only half the story? It's like our planet has two completely different operating systems. One we know, and another, massive one, that runs on a totally different set of rules, deep under the ocean. So today, let's dive into this tale of two worlds. Yeah, 70%. Just let that sink in for a second. That's how much of our planet's surface is covered by marine ecosystems. It kind of flips your perspective, doesn't it? The world we live on, all the continents, mountains, and forests, is actually the smaller part. The real face of our planet, well, it's blue. It's this huge, connected underwater world. Okay, so that naturally leads to the big question, right? We've got these two massive systems existing right next to each other. But how do they really work? I mean, what are the fundamental rules that dictate how life survives on land versus how it survives in the sea? Let's get into it. All right, Section 1, one planet, two worlds. And to be clear, we're not just going to list off a bunch of different animals. No, this is about getting to the heart of it, understanding two totally different blueprints for how life operates, all happening on this one amazing planet. So first things first, let's make sure we're on the same page with the keyword ecosystem. The simplest way to think about it is like a community. You've got the living parts, they biosinosis, all the plants and animals, and then you've got the non-living environment they're all interacting with, the biotopo. That's the soil, the water, the sunlight, the stage where all the action happens. Now, it's super easy to just focus on how different land and sea are to see them as total opposites. But before we get into all that, let's talk about the common ground. Because believe it or not, they share some really fundamental rules. Okay, so what do they have in common? Well, for starters, both are built on these incredibly complex webs where everything is connected. They both act like the planet's life support systems, regulating crucial things like the carbon and nitrogen cycles that literally keep the planet habitable. And of course, they are both absolutely packed with biodiversity. But, and this is a big one, they also share the same weakness. Both are really, really vulnerable to what we do, to human impacts and to climate change. All right, so we've covered the common ground. Now let's get to the really fascinating part, the key differences. This is where you start to see the totally unique character of each world come to life. Okay, let's break this table down because this is huge. The biggest difference, hands down, is the medium life lives in. On land, it's soil and air. In the sea, it's salt water. And that one single thing changes everything. Think about it. On land, the biggest struggle is often finding water. In the ocean, well, water's everywhere. The problem there is getting light, which disappears the deeper you go. Land has to deal with crazy temperature swings, right? The ocean is way more stable temperature-wise, but then you've got to deal with things like intense pressure and different salt levels. It's a whole different ballgame. And this all boils down to one ultimate limiting factor for each world. For life on land, it's all about water. The entire game is finding it and holding on to it. Every single adaptation, whether it's the spines on a cactus or the hump on a camel, is a solution to that one problem. But for marine life, it's all about light. The sun's energy is the prize, so life has to scramble for it near the surface, leaving the massive dark abyss to play by a whole different set of rules. So if you have these two totally different rule books, how does life actually cope? Well, it gets incredibly creative. These challenges, they're the engine of evolution. It's what makes the story of life on this planet a story of just amazing adaptation. And that's really what adaptation is, right? It's just evolution's answer. It's the toolkit, all the changes to an organism's body and how it functions that lets it not just survive, but actually thrive in its own unique environment. And the results are just, wow. To solve the problem of breathing, you get lungs for air and gills for water. For getting around, you get legs for land and fins for the ocean. How do you support your own weight? On land, you need a strong skeleton to fight gravity. In the water, you can just use buoyancy. It's like nature wrote two completely different playbooks to solve the exact same basic problems of survival. To really bring this home, just picture it. Think of a super dense tropical forest, maybe somewhere in Ecuador. It's thick, it's humid, it's just buzzing with sound and life. Now, contrast that with the Great Barrier Reef. It's almost silent, you're weightless, and it's just this incredible explosion of color and movement. Both are just teeming with life, right? But they are built on principles that are worlds apart. But here's the thing. For all their differences, these two worlds have one very powerful, very inescapable connection. And that's us. They aren't sealed off from each other, not at all. What we do on land has these massive, profound ripple effects that cross the shoreline and go deep into the ocean. And this leads to a really heavy question from the source material. Thinking about growing ocean pollution and ongoing deforestation, what are the ethical and socioeconomic impacts on the communities that rely on these ecosystems? When we alter them, what's the real human cost? It really makes you stop and think beyond just the science. And here's where that connection gets painfully clear. A problem on land, like deforestation or agricultural runoff from farms, doesn't just stay on land. It all eventually washes down rivers and straight into the ocean. And what happens then? It can create massive dead zones, choking out vital ecosystems like coral reefs and mangroves. A terrestrial problem becomes a marine catastrophe. So, that leaves us with this final, really important question. If these two worlds are so deeply connected, does it even make sense to treat them as separate issues, to try and protect them in isolation? Or is an integrated strategy one that sees them as a single whole, absolutely essential for the future health of our entire planet?